In this class, we are going to see how to draw an ellipse. Okay. When you see the paper, there is a statement of question from the points from the data which are available on the questions. We are going to draw the ellipse. Ellipse is a plane curve, and we know that based on the eccentricity, we name the curve, different types of plane curves. The given statement is a fixed point is at 60 mm from the fixed straight line, and draw the curve when eccentricity is 2 by 3. It's very important. Eccentricity is 2 by 3. Also, they asked us to find out which type of curve you are going to draw. So, after the completion of the given curve, we are using these two values. One value is 60 mm distance of a fixed point from a straight line, and the second given data is the eccentricity. Based on these two data, we need to draw the curve. After completing the curve, we must give the name of the curve. Then lastly, they asked us to draw tangent and normal to the curve, specifically by using point B, and also they have given the location for fixing the point. It is 65 mm from the straight line. As of now, we don't know which type of curve we are going to draw, but it is very easy to find out the type of curve what we are going to draw by using the eccentricity value. In general, in the case of conic sections topic, we know that if the eccentricity is equal to 1, then it is a parabola. If your given eccentricity small v is less than 1, then it is an ellipse. If your given eccentricity in the problem statement is greater than 1, then it is a hyperbola. And if your eccentricity value is equal to 0, then it is a sub. Okay. Now come to the problem statement and concentrate on the second sentence of the problem statement. It is having the eccentricity value as 2 by 3. So we know that E is equal to 2 by 3, and which is less than 1. So we can say that the given problem statement is used for drawing an ellipse. That means we are going to draw an ellipse. Okay, let's see how to draw an ellipse. It's very simple. Okay, take your scale and pencil, come to the left corner of your paper and draw a perfect vertical line like this, and the name of this line is directrix. Name of this line is called directrix, and it is a vertical line, and name the bottom endpoint as capital A and top endpoint of that line as capital B. Then after that, approximately at approx center of this vertical line, mark one point, then place your cursor on that point, then mark 90-degree point. Then take your scale, and draw a horizontal line from that point to the whole distance, and this point is called C. This point is called C, and the right side end can be marked as E. CE is called the axis. CE is called the axis of symmetry. Simply it is axis. Simply it is axis. Then after that, come to the problem statement. The first sentence is having a distance of 60 mm, and this 60 mm should be marked on a straight line from a fixed point. And in this case, the fixed point is C, and on the straight line, I want to mark 60 mm. So take your scale and place the scale like this, then mark 60 mm point, mark a 60 mm point on the horizontal line. Here I have marked a darker point, but it is not good. For visibility I have marked like this. A point should not be having any diameter or dimension. It should be marked like this. For video purpose I have marked the point like this, and the name of the point should be marked as capital. The name of the point should be marked as capital F. Capital F. This F point denotes that it is the focus. It is the focus. The distance between C to F is given in the problem as 60. So I am marked capital. Then next, come to the second sentence. It has the eccentricity value. It is 2 by 3. and the ellipse can be drawn by using various methods. In this class, we are drawing the ellipse based on eccentricity method. So I am taking the eccentricity value. The given eccentricity value we have already discussed, E is equal to 2 by 3. Add the numerator and the denominator of the eccentricity value, it is 2, and the denominator value is 3, then the sum will be 5. In eccentricity value, the distance between directrix and the focus should be divided into number of equal parts. How many number of equal parts? That number of equal parts can be fixed by using this eccentricity value. Add a numerator and a denominator, it gives 5. So I want to divide this 60 mm distance, which is the in between distance of directrix and the focus, into 5 equal parts. So 60 divided by 5 is equal to 12 mm. So one division is equal to 12 mm here. So take your scale and place the scale like this, and then start to mark the divisions. That means 5 equal divisions. For marking those divisions, we need one division distance, one division length, or one division value, it is 12 mm. So for first 12 mm, mark 1 point, and then next 12 mm, and for third division, mark 12 mm, and then for marking fourth division, and lastly it is. Okay, now I am going to count how many divisions I have created. 1, 2, 3, 4, 5. My numerator and denominator addition gives 5. So it is correct. In eccentricity method, for dividing the in between distance of C and F, what will you do? It's very simple. Take this value of C and F and use the numerator and denominator sum value, divide that CF distance by this addition. 2 plus 3 is equal to 5 for this problem. In some problems you will be having 3 by 4 like that. Whatever may be the numerator and denominator, add that numerator and denominator, you will be getting some sum on value, and this value can be used for dividing this C and F distance. Then you will be getting one division length. Use this one division length and divide that C and F distance, C to F distance. Then finally check it. I want to divide it into 5 equal parts. So first part, second part, third part, fourth part, fifth part. Successfully I have divided. Then after that, again come to the eccentricity value. It is 2 by 3, 2 by 3, and concentrate on the numerator. Draw a circle like this, then write from focus, from focus. Why I have written like this? Come to the focus. This is the first division or first part, and this is the second part. At the end of the second part, at the end of the second part, write capital D. Right? Capital D. It is called vertex. It is called vertex. In order to mark the vertex point, that is denoted by the letter capital D, you must concentrate on the numerator for better understanding purpose. For not committing errors, you just draw one circle on the numerator and then write from focus. That means you are going to draw the mark the vertex point from focus point. I have already marked the focus point here. It is capital F, and at the end of the second division or part or segment, I want to mark my vertex. So from F, focus point, this is the first segment, and this is the second segment end. At the end of this segment, I have marked capital D. This is called vertex of this. Okay. The next step, very easy. Take your protractor. Protractor, if you have protractor, you can take it. And then I need to draw a vertical line from point B. It should be a perfect vertical line. If you have set square, you can use set square also. So I'm just joining the 90-degree point what I have marked here and point D using a vertical line. Extend the vertical line up to this distance like this. No dimensions for this vertical line. Simply extend the vertical line. The next step is very easy. Take your compass. Take your compass. I'm having a compass here. I'm just placing my steel tip of the compass on point D, and I'm measuring the distance of D to F. Then I'm just drawing one upward direction arc and then downward direction arc. This arc cuts that already drawn vertical line at top area and bottom area. Thereby it creates 2 points, one is at the top, another one is at the bottom of this vertex line. Then give the name for those 2 points. The top point is capital G and the bottom point name is capital G1. These notations may vary from textbook to textbook. I am following these standard notations. Then after that, what we will do is very simple. Use your scale and join capital C and G1 and extend the vertical, extend the line up to the whole length of your paper. Then next, in the same way, join capital C, capital G and extend to the whole length of the. Then next step, very easy. Take your scale, place your scale 0 on point D, on point D. Then after that, mark 5 mm, 5 mm, 5 mm, marks like this, 5 mm, 5 mm, 5 mm. Okay, once again I will repeat. After joining CG1 and CG, the next step is concentrate on the vertex point D and place your 0 of the scale on point D, and then on the horizontal line you need to mark 5 mm, 5 mm, 5 mm, 5 mm distance points. So after how much distance I want to mark these points? It's very easy. It's very simple. You can mark n number of divisional points. It's your wish. In my selection, I always mark up to 200 mm. That means in your scale up to 20 centimeter you need to mark divisions. Okay. The next step is to give name for those 5 mm points. For better visibility, I will write using this blue pen. Mark the first 5 mm point as 1. Don't mark this one on point D because already D has marked here. So start to mark the points after point D. So after the point D, this is the first division. So I am marking 1, and next point is 2, and 3. Next one is 4, and this is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Okay. Next, again take your protractor, flow circle or set square because we are going to draw vertical lines from each divisional point, and the condition is all those vertical lines what you are going to draw should be parallel to this G1 vertex line. So the first vertical line is to be drawn through point 1, So I'm placing my draw circle on point 1, then I'm just marking the 90-degree point. Then the next vertical line is 2. The next one is 3. The next one is, next point is 4. And the next point is 5. Next one is 6. And 7, 8. And for 9. And for 10. And that is for 11. And 12. 13. 14. 15. 16. 17. 18. 19. And it is 20. Up to 20, I have marked perpendicular points. So now I'm going to join each of these perpendicular points with its respective axis point. Looks like a time-consuming process. Upon continuous practice, you can easily draw these plane curves very easily. Okay. Next, it's very simple. Mark the names for the top points. This is 1 on the horizontal line. So at the top on this angle line, CG line, it is to be marked as 1 dash, like that. 2, so this is 2 dash, and this with 3 dash and 4 8 dash, 9 dash, 10 dash, 11 dash, 12 dash, 13 dash, 14 dash, 15 dash, 16 dash, 17 dash, 18 dash, 19 dash, 20 dash. So I have marked the points in the top CG line. The next, it's very important. I will tell a clue for easily completing the plane curves. That means for drawing parabola, ellipse, hyperbola. A simple clue is that it's very simple. Same center within bracket by capital F, but different radius. What is the clue for drawing conic sections, plane curves, parabola, hyperbola, ellipse? Simple clue is say center within bracket right capital F and different radius. So all I know that from the clue is I want to use the center as focus point, but the radius will be different. Okay. First, come to one dash vertical line. Measure 1 to 1 dash distance like this by using your compass. By using your compass, measure 1 to 1 dash distance. This is the radius. This is the radius, and we know that from the clue, I need to use center as capital F. That means my focus point is my center, and the radius is 1 to 1 dash. So I have measured 1 to 1 dash distance by using the compass, and now I am going to use F as my center. So I am placing my steel tip of my compass on point F, and then I have drawn and I am drawing one arc on the 1 dash vertical line at the top area.